Oh, yeah. 9.2. Mean. Oh, I love this topic because I feel like it describes my personality. No, I'm just joking. I don't think I'm that mean. All right. How do I find? Whoa, 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 whoa. The mean. And in our case, we're going to say or average of a data set. All right. How do I find the mean or average of a data set? And then we're going to use that mean to describe our data. So let's go straight to the key idea. The key idea today is a mean is a type of average. And for our purposes, we're really going to connect these two words. Okay, mean and average mean the same thing. You'll see why, especially since you've already learned about average in the past. Okay, the mean of a data set. Wait, data set. Oh yeah, that's right. When I ask a statistical question, one where I get different factual responses, right, and I create a data set, that's this is the analysis using statistics, right? And it is the sum. So the mean of a data set is the sum of the data divided by the number of data values. So say you had these data, which is like, I don't know how many Oreo cookies you eat every hour. You eat eight the first hour, 5 the second, 6 the next, and 9 the next. So there are different factual numbers of cookies that you're eating every hour. Well, it says find the sum of the data. Well, these are the data. What does sum mean? Add them together. So the sum of the data, that's here. That's adding together all of the data in the data set. And then it says to divide by, and I don't know if you guys can see this. Oh, I don't even know why I'm drawing these like weird circle connection things, but the number of data values. Okay, well, how many data are there? 1, 2, 3, 4. So we divide by 4 because there are 4 data values. So you add all of the data together, you find the sum, you divide by how many data there are. 28 divided by 4 is equal to 7. So the mean of this data set is 7. And just for now, look at the data set and think about the number 7. Isn't 7 a pretty good, one number summary of what this data set says? You're eating about 7 every hour. So instead of giving the whole data set, well, I ate the first, 5 the second, instead of saying all that, you could just say, I'm eating about 7 every hour. And another way of thinking of the mean is that it's the balancing point in the data. It's the point at which all the data would be balanced on the left and right side of it. But we'll have to save that for another time. Let's jump into our first example here. And the question on the right says, how do you find the mean of a data set? Well, we kind of already learned that process, but we're now going to apply it to our own data set. Okay, how old are the members of your table group? That was originally what we're going to do in class, but we're not in class. And then we're going to find the mean. Okay, well, the first thing we're going to do is make a data set. So all of you sat in table groups of 3, 4, or 5 people. And so if I'm going to pretend that this is a 5-person table, okay? So you're all 11 or 12, maybe 10 since I have some 5th graders, but let's say, all right, there's the 5th grader. There they are. 10, 11, 12, 12, 11. I don't know. I'm making it up. I don't actually have the data. So here we go. We have all of these data. How do we find the mean? Well, the mean is like the average. You first find the sum of the data. That's 10 plus 11 plus 12 plus 12 plus 11. And the way that I'm going to do this is, how many groups of 10 is this? It's 5 groups of 10. That's 50. Now I'm going to add the ones. That's 1 plus 2, 3, plus 2 is 5, plus 1 is 6. So 50 plus 6, that's 56. Okay, now the mean, we're going to take that sum, 56, and we're going to divide by, oh, this is the part that everyone forgets. We're going to divide by how many data there are. 1, 2, 3, 4, 5. So we're going to divide by 5. And I left myself plenty of space, as you can see. Beautiful. Okay, how many 5s go into 56? Well, there are 11 whole groups of 5, right, which gets you up to 55. But then we're going to 56. That's one left over out of 5 that make a whole. The divisor is always the number that makes the whole. 11 and 1/5. And some students always ask, can I write that as a decimal? Of course. That's 11.2 or 11 and 2/10. And once again, when we find the mean, 11 and 2/10, isn't that a pretty good description of these data, right? It's a good balancing point. If I said, how old are the members of your group? About 11, a little over 11 overall, even though we have two members that are 12 and a member that's 10. Okay, the mean is also called we talked about this, the average. To find the mean, first find the blank of all the data, the sum. Probably should use total there, but that's okay. Sum of all data, then divide your sum by the number of data. Or I should say values, huh? Oops. Maybe this should have been values. The number of values, which are numbers. Values. Ayabuka. In the data set. I think you understand what I'm after here. 1, 2, 3, 4, 5. It's how many data there are in the data set or how many values there are in the data set. Excellent. Let's move on. I'm just going to assume you get it because you're all so hardworking. Growth mindset. All right. Oh, see, there's just that little bit that I'm afraid you're going to miss. Okay, there we go. Question. How can you use the means to compare the data? Okay, the double bar graph. Oh, if your life wasn't hard enough with one bar graph. Double bar graph shows the monthly rainfall amounts for 2 different cities over a 6-month period. We're going to compare the mean monthly rainfalls. Whenever I do a question like this, it takes me a long time to sort out what's going on in the both in the question that I'm being asked and in the information that's being given. One thing to do here is if I'm comparing the mean monthly rainfalls, think about what my answer is going to look like. So I have 2 cities. They're going to be 2 different means, and I'm going to compare them. And since mean is kind of that that value that you expect. We also call it the expected value later in math. It's going to kind of tell us which city's getting more rainfall, right? Generally. So city one, okay, well, let's see. Here's the month, 6-month period, November, December, January, February, March, April. Okay, city one's this darker green. 3.5, 2.2, 1.9, 2.1, 2.5, 3.4. It looks like it is, well, I can't tell because it has so much rain these months, but it has less these months than the second city. I don't know. Well, I already found the mean of the first city. That's 3.5 plus 2.2 plus 1.9 plus 2.1 plus 2.5 plus 3.4, all divided by 6. Why 6? There are 6 months of data, right? And I got about 2.6. Well, now we're going to do the same thing with city 2, right? City 2 is this lighter color. So it's 1.7, 1.6, 2.2, 2.1, 2.7, 1.7. Based on what I'm seeing, I think the mean's going to be less for the second city. But, you know, we'll just have to find out. First step in finding the mean, find the sum. Okay, I'm going to find the sum of that data then. 1.7 plus 1.6 plus 2.2. Oh, 2.2 plus 21. No, 2.1. I know you guys all love that number 21. It's your favorite number. 2.7 plus 1.7. Oh, jeez, that took forever. Divided by 6 months. Now I'm going to get out my trusty calculator here. Oh, it's beautiful. Okay, 1.7. I'm using my mouse. I should type this in, but I've already committed. plus 1.6 plus 2.2 plus 2.1 plus 2.7 plus 1.7. All those are about 2, right? So I should get a sum. 6 groups of 2 should be near 12. Oh! Ugh! It's exactly 12. I'm very impressed with myself, I gotta say. It's, look, when you're inside all day, sometimes you get impressed by slight things. So this was 12 divided by 6, so the average is 2. So city 2 has only 2. And I should now write the answer to the question. What's the answer to the question? Well, the answer to the question is city 1 has a greater mean. Greater mean. It's like my class. I'm the greater mean. I'm going to put in parentheses here. I'm going to really be scientific, which is 2.6, right? The mean for the city 1. Maybe I should label this. Oh, yeah, city 1. Oh, it's so beautiful. Oh. I'm going to slowly make this Y. Hey, maybe in a couple years I'll get it. City 1 at 2. Oh, that's not what I meant to do. City 1, 2.6 is greater than city 2. Come on, Y. That's all right. It looks more like an X because that little bit right there. Hold on, I can fix it. Look at that. Oh, so to pay me the big bucks. Okay, city 1, 2.6 is greater than city 2, which is 2. City 1 is a greater mean, so it generally it's a good Y. So generally receives more rainfall each month. More rainfall each month. Okay, excellent. We've answered the question. I know I have. I've suffered. And while you're like, I don't want to write that, I suffered, okay? Just remember that. I suffered.